So chapter one, section one talks about like definitions, probability, and key terms. So what is statistics? So statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. There are statistics all around us. There's data all around us, and it's heavily involved in the types of products that you use in your hair, the food you eat, what kind of medicine should we take, and so there's statistics is everywhere, and it really does contribute to society in many aspects. Okay, so here there's a cool video. I'm gonna put this link in Canvas so that you can watch it. It's really helpful as well. Okay, so let's talk about an example. So suppose we wanted to know the average time that a stats student sleeps per night. So let's suppose we take our class and we record the data, and then we create a simple graph of this data. So let's say so-and-so sleeps 5 hours a night, so 3 people, or no, so one person sleeps 5 hours, another person 5.5 hours, 3 people sleep 6 hours a night, and 4 people sleep 6.5 hours, 2 sleep 7 hours, 2 8, and then 1 person is lucky that they average 9 hours a night. So if we were to plot this data, it would look like this. So you see here, this is the number of times people average 7 hours a night. So that's 2. And then this number of numbers is called the frequency. So the number of times that something occurs is a frequency. So we'll see that again. Okay, so descriptive statistics. So when you organize and summarize data, it's called descriptive statistics. So it's basically like, here's everything on a graph, and here's everything on a pie chart. These are, students that are at De Anza full-time, and here's the number of students that are there part-time. It's descriptive. You can see it, and you can, it gives you information. Okay, so inferential statistics is, it's this. So once you have descriptive statistics. Let's say you have your data, you have stuff going on. There are ways to draw conclusions from this data. Okay, so we call that, the methods that we use are called inferential statistics. So we're basically saying, okay, well, I have all this data. What do I do with it? Well, you can run a test on it. And this is all stuff that we're going to learn together. So I'm very excited. All right, so what's the goal? What is the goal of statistics? It's not to just perform a bunch of calculations and understand difficult formulas, but it's actually it's about understanding these numbers, and it's about using these numbers to make a decision, right? So if we can grasp the basics of statistics, you will be more confident with a lot of decisions that you make in life, and you'll base your decisions on fact and reasoning and data versus just, emotion, so it's pretty powerful. Okay, so let's define probability. So, probability is something that is a tool that we use to study randomness. So what does it deal with? So what does it have to do with? It's how possible is this event likely to occur, okay? So let's say, for instance, if you toss a coin 4 times, the actual outcomes may not be 2 heads or 2 tails, but if you toss the same coin 4,000 times, you're probably half the time will be heads and half the time tails, okay? So it's kind of the chance of, you have, like, we use probability all the time, like 50% chance of this happening. This is 75%. This is really unlikely, likely. Okay, so stats is based on this theory, okay, of probability. So how did probability begin? So let's say it started in game theory, has its origins in game theory. So like, for example, poker, games of chance. So what else is interesting? So let's say we want to predict the likelihood of an earthquake or rain or whether we'll get an A in this class. We use probability. Doctors use probability to determine the chance of a vaccine actually causing the disease versus preventing it. Okay. So let's go over some key terms. So what's a population? So key term is population. What is a population? In statistics, we study populations. We can think of a population as either a collection of people, of things, or objects under study. So let's say, a population could be anything. Let's say like we're thinking about, Latina women aged 30 to 40, that's a population. Kids, American kids that are, 11 to 12 that play video games. There's just population is a group of people that we're thinking about, we're considering, we're studying them, or things or objects as well. Okay, so so let's say, for instance, here, let's take this situation. We want to know the average amount of money first-year college students spend at San Jacinto College on school supplies that do not include books. So let's suppose we randomly ask 100 students at this college, and 3 of the students spent $150, $200, and $225 respectively. So what do you think in this situation the population might be? So in this example, the population would be all the first-year students attending this college this term. Why would it be that? It's because we want to know the average amount of money first-year college students spend at SJC on school supplies that do not include books. So we're studying these first-year students, okay? So that's the population. That's the group that we're taking an interest in and that we're thinking about. Okay, so usually, like most of the time, it's not realistic to study an entire population. So like if I said, women in general, or you're not going to go and talk to however many billion women that are on the planet. That's ridiculous. Like we can't do that. We are not able to reach every single person in that population. So to effectively study a population, we take what's called a sample. A sample, it's basically like you're taking a little subset or a portion of the larger population, and we study that piece, that subset, that group of people, to gain information about the population as a whole. Okay, so you might think, well, wait a minute. If you get a subset of a population, how do you know that it effectively portrays everybody? Like that doesn't make sense. That could be wrong. Well, you're correct in thinking that, because that's why what's really important is that we have proper sampling methods, and we're going to get into that as well. So there's ways that we can ensure that our sample is a proper representation of the population that we're trying to study. Okay, so going back to this example, what would be the sample? Okay, so we want to figure out. We were studying the population of first-year college students here, and what's the sample that we take? Okay, so in this case specifically, they take 100 first-year students at the college, right? So that's a sample. Another example of a sample could be all students enrolled in one section of a course. So all of us, we're not at SJC, but if we were, we could be a sample theoretically, okay? So what's a subset? Okay, so next. So a parameter. So what is a parameter? It's a parameter. A parameter is a number that describes a property of the population. So how can we actually say we could describe this population with solid numbers? Well, that's why sampling is practical, because it really is very difficult to examine an entire population. Okay, So, so let's think about this. So, what is the parameter? We want to know the average amount of money first-year college students spend at San Jacinto College on school supplies that do not include books. So, right away, can you determine the parameter? You guessed it. It's the average amount of money spent by first-year college students at San Jacinto College this term. Well, why is this the parameter? Because it's a number, the average. Average is a number, right? It's an amount of money. And it's a number that describes the population. So this money is spent by the first-year college students, okay, our population. Okay, so the parameter is connected to the population. It's basically a number that's describing or a property that describes the population. Okay. All right. So let's define statistic. Okay. Now, just as parameter is something that describes the population, a statistic is a number that represents a property of the sample. Okay. So let's like really think about that. Let's really like let that sit into our brains. Okay. So parameter, population. Statistic, sample, connected to the sample. The statistic represents property of the sample. So let's say, for instance, if we consider one math class to be a sample of the population of all math classes, okay, then let's say we take that one math class and we average their points. We find some kind of number describing this math class. Well, that's a statistic, okay, because it's a number that's describing something about the sample, okay? All right. So let's think about the statistic in this super fun example that we're going over. So let's see here. We want to know the average, right? We survey 100 first-year students, and 3 of those students spend 150, 200, and 225 respectively. So the statistic in this case is the average amount of money spent by first-year college students in the sample. So really important that you're thinking about the sample. Okay. All right. Continuing. Variable. So a variable, it can be notated by like capital letter like as X or Y. It's something of interest for each person or thing in a population. And you might think, well, that's kind of general or that's kind of broad. But yeah, variables are broad. You may have been introduced to the word variable in an algebra course, right? Let's solve for X. It's sort of like that, but it can be more broad because it doesn't necessarily just mean a number. It could be, it's just something, it's a characteristic. So what are we interested in? What are we trying to figure out? Oftentimes it does end up being a number or representing a group of numbers, but it's just another way to describe a characteristic. Okay, so let's say here, for instance, we have the same situation. What would be the variable? Okay, so an example of a variable could be the amount of money spent by one first-year student. Okay, so that's something that's of interest. Okay, so X could be the amount of money spent by one first-year student attending SJC. Okay, so, of interest, you have variables could be either numerical or categorical. Okay, so this is important. So their definition is in the name, right? Numerical values take on values with like equal units, like such as weight in pounds or time, and categorical variables place the person or thing into a category. So if we let X equal the number of points earned by one math student at the end of a term, then X is numerical. But let's say we let Y be a person's party affiliation. Let's say, for example, Republican, Democrat, Independent. So Y is a categorical variable because it basically, it's not numbers, it's categories. Okay, Okay, so what is data? Data are actual values of the variable. They may be numbers or they may be words, and datum is a single value. Okay, so let's determine this data now. Okay, so we have the same situation. In this case, what would be our data? or data would be the dollar amount spent by the first year students. So examples of this would be, of the data that we're collecting is $150, $200, and $225. So here is your super fun homework. Okay, so in your textbook, the online textbook, you can click on table of contents and go to chapter 1. In the bottom, there's a section called practice. Okay, so you click on that, and I want you to work the first 5 problems. So it kind of summarizes and talks about what this video has been. Okay, so write it out. There will be a section for you to submit it on Canvas. And good luck, and I'm excited. If you have any questions, please feel free to contact me, and I will see you in the next video.